Hello everyone, welcome back to my YouTube channel after a long time. First of all, subscribe my channel for more updated videos. Today our topic is how to calculate cooling capacity or coil load from a psychometric chart. First of all, we will discuss about the psychometric chart. This is the psychometric chart by ASHRAE. It's based on SI units, System International Units. In this, the horizontal line is for dry bulb temperature. These curved lines are for relative humidity. These lines representing the specific volume of air, and these lines that's toward the 70 toward 80. These are the wet bulb temperatures, and this curved line is for saturated temperature, and this line is for enthalpy. So today we will discuss how to use a psychometric chart to calculate the coil load. So here we have one case in which the outdoor air dry bulb temperature is 41.11 centigrade and wet bulb temperature is 87.8 centigrade, and the design airflow is 1240 CFM, and we have to supply air from 41.11 centigrade to 12.7 centigrade to maintain a 24 Celsius temperature in room. So we will start from a psychometric chart. Before starting, we will discuss, we have these equations to calculate the cooling capacity, cooling load or coil load. So in this we will require a volumetric flow rate, which is also known, we have a 1240 CFM, which will be converted to meter cubic per minute. So to balance the equation, so we multiply this CFM with 0.28, convert this to meter cube per minute, and we will calculate this specific volume of air from psychometric chart, inlet enthalpy and outlet enthalpies. So we will calculate these three parameters from a psychometric chart to calculate the coil load. So here we will start. You can see the temperature is 41.11 centigrade, so we have just started from 41.11 and will move toward the 50% relative humidity. So the outdoor temperature is 41.11 at a relative humidity of 50 degrees centigrade. We are going to cool down this temperature up to 12.7 centigrade to maintain a 24 centigrade of room temperature. So we will touch this 50% relative humidity, and we will cool down this temperature toward the 12.7 centigrade. So is 1 2 3 4 up to 12, and this is 12.7 centigrade. So we will touch this curve when we are decreasing the temperature from 41.1 centigrade, it will touch the saturation line and we're going to decrease up to 12.7 centigrade. So we will check at these 2 points. One point is this one and second point is this one. We will check the enthalpies at these 2 points to calculate the cooling load or coil load. So you can see at this point the enthalpy is 100, 1 2 3 4 5 6. It's equal to 106 of kilojoule per kilogram. So we just put the value of 106, which is at 41.1 centigrade, and the second enthalpy is 12.7 centigrade, which is at this point it's equal to 30, 31, 32, 33, 34, 35, 36, which is equal to 36. So we just put the value of 36. And what's the specific volume of air? Here these are the lines for a specific volume of air. here you can see it's 0.92, and here it is 0.93. so this point is in between the 0.92 and 0.93. so we have just assumed that it's 0.925 meter cube per kg. So just put these value, the coil load will be calculated by this equation, which is mass flow rate of air into difference of enthalpies. So how we calculate the mass flow rate? We just calculate the mass flow rate by dividing the volumetric flow rate by the specific volume. We just divide this one by this to calculate the mass flow rate. So we just calculate the coil load, which is around about 12 ton of refrigeration equal to 43 kilowatt. So for this case we just need a 12.4 or 12.5 ton of refrigeration to cool down this 41.11 centigrade at 50% relative humidity to 12.7 centigrade. So these are the all scenario to calculate the coil load. So thank you for watching my video.